Hello, my name is Cary Jensen, and welcome to FireDAC in Depth. Let me introduce myself. I'm Chief Technology Officer at Jensen Data Systems, and I have 30 years of experience as a professional developer, consultant, mentor, and trainer. I'm the author of more than 25 books on computer software, including my latest book, Delphi in Depth, FireDAC, and my prior book, Delphi in Depth Client Datasets. I was the original author and trainer for the Delphi World Tour from 1995 through 1999, and that covered Delphi 1, or Delphi as it was called then, through Delphi 5. In 2001, I co-founded Delphi Developer Days with Loy Anderson, and during that time I've had the pleasure of working with some of the big names in Delphi as co-presenters, including Marco Cantu, Bob Swart, Ray Konopka, and in 2016, Nick Hodges. In 2017, and this fall, Bob Swart will be joining me once again for a new round of Delphi Developer Days and a special database edition of Delphi Developer Days, and I'll say more about that at the end of this talk. In this talk, FireDAC in Depth, I'm going to begin with a brief overview of FireDAC, followed by a discussion of 5 topics that I think are important for every FireDAC developer, including configuration inheritance, the SQL Command Preprocessor, FireDAC dataset persistence, array DML, and cached updates. FireDAC is a comprehensive data access framework that ships with RAD Studio. There are a number of data access frameworks supported by RAD Studio, but FireDAC has quickly become the preferred component library for data access, providing you with access to a wide range of databases, including file server-based databases and remote databases. FireDAC provides the most complete support for the Dataset API, offering a smooth migration path for legacy applications. This is particularly important for developers who began using the BDE, or Borland Database Engine, and now need a replacement since the Borland Database Engine has been deprecated for a number of years. And FireDAC provides that completely. It is the most complete support for T-Dataset, and it is very easy to migrate from the BDE to FireDAC. In fact, RAD Studio includes a feature called Refind that helps you in that process. One of the notable characteristics of FireDAC is it supports a large collection of advanced capabilities, and I'm going to focus on the 5 that I mentioned earlier: configuration inheritance, dataset persistence, the SQL Command Preprocessor, array DML, and cached updates. There are many other advanced capabilities in FireDAC, but given the duration of this webinar, these are the 5 that I felt would be most appropriate to discuss in this format. So let's begin by looking at configuration inheritance. I picked configuration inheritance because it's one of those characteristics that is particular to FireDAC, which is it is highly configurable. And those configurations allow you to fine-tune your data access. And what's so important about this is that you can fine-tune your data access to improve performance, but if you choose the wrong settings, you might actually hurt performance. Over the past several years, I've seen a number of posts online where developers have complained that FireDAC is not doing things correctly, and here's the problem. And in almost every instance, it's actually misconfiguration that is the cause of those issues. And so therefore, that's why configuration is so particularly important. If you look at the other data access frameworks within RAD Studio, you'll find that few of them allow for really low-level configuration, but FireDAC does. FireDAC has dozens and dozens and dozens of properties that have an important impact on how your software accesses the database. One of the characteristics that's particularly interesting about FireDAC is that it has a set of 4 properties that are inherited by a collection of central data access components. The top level component in this inheritance is the FD Manager, which is a singleton object. If you do not place an FD Manager within your project, there is one created for you before any of the FD connections are created. It's as part of the creation of the FD connections. If you place one manually at design time, then you can directly configure that FD Manager at design time. Otherwise, you can actually control the automatically created FD Manager at runtime through runtime code. The FD Manager settings on 4 properties, including fetch options, format options, resource options, and update options, are inherited by any FD connections that you've placed into your application. Furthermore, FD datasets, including FD query, FD stored proc, and FD table, inherit the properties from the FD connection to which they're connected. FD mem tables do not use a connection. They're in-memory tables. They inherit their properties directly from the FD manager. What this inheritance means is that when you set a property, for instance, in an FD manager, all of the FD connections connected to that manager will adopt that particular collection of settings. Furthermore, FD datasets such as FD queries and FD tables attached to that connection will also inherit those changes. What's important to note, however, is that the individual components in this hierarchy can override settings. For instance, you may have one particular FD connection that always fetches all records when a query is executed before continuing, and you may have another FD connection that just selects enough or extracts enough records to be able to let the component start doing their work, and will continue to extract additional records from the underlying database as needed, so that those FD queries connected to one of the connections will always get all the records before continuing, and an FD query connected to the other connection will get its records and actually be able to process more quickly, but will have to fetch records incrementally as you continue to work with the query result. So let's go over and look at Delphi now and take it and actually look at how this configuration works. So here I have an FD manager placed on a form. These properties that I'm talking about are found here. Here are the fetch options. And notice the fetch options itself is a property. In this case, it's a TFD fetch options. And then there are properties of this particular object that is supporting the properties in this FD manager. Here are the format options. Here are the resource options. And here are the update options. So let's actually take a look at the inheritance. Let's go ahead and look at the fetch options of this FD manager, and note that the default mode option is FD on demand. That is the property that controls whether the individual FireDAC datasets will retrieve just some records of the result set or all records of the result set when you execute a query. FD on demand says go out and get a certain number of records, and it's based on row set size. Actually, it goes out and typically gets about double the number of rows as row set size. However, if we set the mode property to FM all, we would get all records before the resulting query returns. Now note that in this FD connection I have here, it also has a value of FM on demand, and this query here has F on demand as its mode as well. If I go to the FD connection and I change this mode from FD on demand to FM on demand to FM all, then the query itself has also changed its mode to FM all because it's inheriting its setting from the connection. Now I pointed out, well, this is true by the way, if you notice, if we go to the stored proc, it's also inherited that FM all, and so did the FD table. But I mentioned that it's possible to override at some particular level the individual settings, and let's do this right now on this FD query. So I'm going to change the mode on this particular query back to FM on demand. The connection still has a mode of FM all. The stored proc still uses FM all that it inherited. However, the query is now FM on demand. What's interesting about this is this assignment is managed. This override is managed through the assigned values property of fetch options. And I should point out that all the other inherited properties also have assigned values. If we go back up here to the fetch options assigned values, you'll notice that EV mode is set to true. The flag is set to true, which means no matter what you do to the FD connection, don't change the mode property on this inherited property. The FD query will have its own value of that inherited property. And that's how the inheritance works. If I were to turn this flag off and go back, we'll notice that the mode has been set back to FMAll. So just to repeat what I'm saying is that settings to properties at higher level objects within this hierarchy affect those components that inherit the properties from that object. It is, however, possible at an individual layer to override the settings and disconnect that inheritance so that subsequent changes to a higher level object will not affect particular property or a particular set of properties in a descendant object. And this gives you a tremendous amount of flexibility and control when configuring your FireDAC components for data access. Specifically, if there is a particular feature that you find that is crucial that all your data sets have, and one of those that I would point out is this update option called Update Mode, where I highly recommend that you use up where all. I've talked about this in other venues, so I'm not going to repeat the argument right now because I have to go into some detail in order to do so. But by changing the update mode to up where all on our FD manager, all of our components are going to use that particular setting. And if we have one or more or a small collection of components that we want to actually have using an update mode of update where key only, we can override those, and that will be respected for the remainder of our application, or that will be respected regardless what changes we make to components higher up. Now, I've shown you setting these properties in the Object Inspector. Fortunately, there is some support for setting these properties in another way, which is, for instance, with the FD connection, we can go to the connection editor. And from the connection editor, this connection has not been configured yet, but we can go to the options page, and what it does is it shows us a more user-friendly interface to the particular options. For instance, we can come down to resource options, and we can expand particular elements that allow us to choose how things are maintained. Notice up here in the update options, we have posting options, and here's that update mode of up where all, and we can change it here to something else. So this gives us help, and we can then even it gives a more this gives us a more user-friendly interface for managing our options. The queries also have this capability. If we go to the query editor, and again, I have not configured this particular component, but we have a similar options page on the query editor so that we can go in and configure this particular query, and in this case, maybe even override something it's inheriting from its FD connection. This next topic is FireDAC dataset persistence. In FireDAC, all datasets support the ability to write to files and streams and read from files and streams. This persistence is supported by 3 different formats: XML, JSON, and binary. Prior to FireDAC, you needed to use a client dataset if you wanted to store your data temporarily in a file or stream and then be able to restore it later. In addition, the resource options.storePrettyPrint property allows you to define that you want to have this XML or JSON content formatted for human consumption, so formatted nicely with indentation. Otherwise, it's just stored as one long stream. So if you need to be able to display the content at some point, or you want to be able to view the content, you can set that property. There are additional properties that support the persistence. One set of properties, which is inherited from the FD connection, allows you to define the default folder and the default format that you want to store your data in. You can also specify that when you open or close the associated FireDAC dataset, it will read or write from a specific file. And that is defined by the resource options persisted and persisted file name, which allows you to define what the file will be that you'll read from when you open and save to when you close. This allows you to create kind of a standalone database. So if you are creating, let's say that you want to create an address list and you want to share it with your friends and family. So a simple address list application, but you don't want to have a database behind it. You could specify a particular file that is opened every time they run the application and closed and saved to when they close the application. And what's really interesting is you can also define that you want backups. And these backups can be every time you open a file and then save it, the backup is the previous version of the file. So if something happens that possibly corrupts this file, you can go to the backup and actually use it. It's a complete earlier version of that data. These are very, very nice features. Another feature of FireDAC dataset persistence, and one that's really quite unique to FireDAC versus any other data access mechanism in RAD Studio, is that you can load more than one file into a given FireDAC dataset. For example, you can load a FireDAC query with a previously persisted file, and then load another previously persisted file into that same FD query. Depending on the properties you set, that data may append. So you may load 3 or 4 files into the FD query, and when you're done, it's the combination of all the data from the 3 or 4 files that exist in the FireDAC query. And the properties also let you define what happens if the structures aren't exactly the same. It is possible to have slightly different structures and still these loading operations work. So this is a very powerful capability that is quite different than most other data sets that you might see. So let's go over and take a quick peek at how this all works. So I have a project here called Save and Load, FD Save and Load, and let me just go ahead and run it, and then we'll actually see what it's doing. When I hit Run Query, whatever query I have up here executes, and I'll go ahead and do that. Code over here allows me to save the data that's in this FD query to a file. And let me do that, and so we can read it, we'll save it using the pretty print capability. I'll say save to file, and I will save it in this directory, and I'll call this, I'll use the XML format too, because that'll be good. I'll say CA records, meaning that these are records from California. And I'll hit save. And let's go ahead now change this and change not to save records from California, but let's extract records from Hawaii. Run the query. There's one record, and let's go ahead and save that. And I will save this one as HI records for Hawaii.html or XML. HI. Okay. Save. And now I'll clear the query so that there's nothing here. I can now use load from file. And this is the store merge options, store merge data property, and this defines how things will be merged together when I load more than one file. And I'm going to say that I want to do a data append, and then I'll say let's go ahead and load a file. Let's get and then I'm going to again load the Hawaii files. Let's go get those. And now you'll see that I've actually got the combination of the records from both the California records and HI records. And that's just one example of storage of data and persistent. I wrote it to a file. What's really important about this is that that file is still there. I can run this project again. I don't have to run any queries. I can say load from file, and if I go back and get the Hawaii records, there they are there. So now, where else would you use a feature like this? Well, one example is that I may have the results of a lot of calculations that have to be performed before I produce a report. The first time I create the report, I may check a database to see if the calculations have already been stored in a table that I could just extract and not have to perform the lengthy calculations. If it's not there, then I perform the lengthy calculations. I have the results in a FireDAC dataset such as an FD query or an FD mem table. And then before I print out the report, I actually save that dataset of calculations into a blob field in a database. The next time I go to print the report, the code goes and looks into the database, and this time it finds that the calculations have already been performed. So it reads from that blob field into a stream and then loads the stream into a dataset, FD query for example, and then I can print the report without having to go through all those calculations that I had previously done. So while we're at it, let's go ahead and take a look at what one of these files looks like. So here's the Hawaii records file. I'll open this up in Notepad. And there you are. There's the pretty print version of the XML that describes this data that we've stored to disk. Should also mention that if we were in a cached updates mode, which I'll talk a little bit about more later in this talk, that the actual change cache can be stored in this file and is stored by default in this file, although we can turn that off if we want to through the configurations that I was discussing before. Okay, let's go ahead and continue on to the next topic. The SQL Command Preprocessor. The SQL Command Preprocessor is an engine that can change your SQL before sending it to a database server. The most common use for this is when you are supporting more than one type of database within your application. A lot of vertical market applications may write to several different databases such as InterBase and Microsoft SQL Server, and the SQL Command Preprocessor is a wonderful tool for writing one piece of SQL that will execute correctly based on the database to which you're attached, and so that you don't have to have two different SQL statements, one for InterBase and one for SQL Server, but rather one that automatically gets manipulated slightly, or in some cases more extensively, prior to being sent to the underlying database. There are two general categories of things that the SQL Command Preprocessor supports. One is macro substitution and the other is escape sequences. With macro substitution, you use variable-like definitions within your SQL, and like a parameter, you assign a value to those definitions prior to executing your query. So this is something that you take charge of. What this gives you that you won't get with parameters in parameterized queries is that these special macros can appear anywhere within your SQL statement. And I'll come back to that in a moment. Those macros are words that are preceded by either an exclamation point or the ampersand sign. Escape sequences are special definitions that can appear within your SQL and are substituted at runtime with something else. So let's go ahead and take a look at both the macro substitution and escape sequences. Okay, over here in Delphi, and I'm using Delphi specifically because I'm a Delphi guy, but this is RAD Studio, obviously. The first I'm going to look at is this project I have here called macro substitution, and there is a data module on here, and let me just show you that data module briefly. It has a query, and this is my query. Select ampersand field list from ampersand table name. This is the query that's actually going to show content on the screen when I run this application. There are two macros. Those macros are field list and table name, which if you go back to the SQL command, you'll notice in this case are preceded by ampersands. That's how Fire DAC determines that they're actually that those are macros that need to be substituted. On this form, when I click Show Data, what I'm going to do is load data, and that data is going to produce two values, one by building a list of field names, which it assigns to a property called field list, and another which is the item that I've selected in the name of the table, which is selected here. The field list is built by a list of fields over here, and in the code all I have to do is assign values to each of the macros. In this case I'm assigning by position, and the values of those macros will be used at runtime in order to provide the content that will take that particular place of the SQL statement. So as an example, I'll select this table and a couple fields here, hit Show Data, and that query will display the data that I selected. I'll select another, here we'll select this one and just a couple fields, and press the wrong button there. Okay, and show data again. And now I got those two fields. Let's add a couple more fields to this and execute again. This is, you're seeing the results of macro substitution. This allows you to place these variables called macros anywhere within your SQL statement. One thing to keep in mind, which is very important, is that you risk SQL injection if you take and assign to a macro data that's input by a user. So it's very important. SQL injection is when you concatenate data entered by a user into a SQL statement that you then execute against a database. A clever user can enter the right sequence of statements to do things that could cause damage or expose your data in ways that you don't want. If you're not aware of the SQL injection hack, please look it up. In Delphi and Fire DAC, I explain what it is and describe how you avoid it. With macro substitution, you actually are opening yourself up to SQL injection if you assign data input by a user to a macro, so beware of that. Escape sequences are these statements enclosed in curly braces, and there's four distinct types: constant substitution, identifier substitution, conditional substitution, and FireDAC scalar functions. Let's look at an example of each one of these. I've stored in the directory with the project that demonstrates this technique, and that project, by the way, is called FD SQL Command Preprocessor, and I've got it already on my favorites list here. And what we can do is we can place a SQL statement in here and click this button to show processor work, and we're going to see in this memo, we'll see the SQL that's actually sent to the database server, and down here we'll see the result of that. My first example will demonstrate constant substitution. Constants or literal values in your SQL statements are represented differently on different database servers. These are the curly braces right here, and this is actually constant substitution. This is saying I'm representing a date, and here's that date in a year, month, day format, but put it into the correct format for this database server. So when you see me hit this button here, what we see is it's changed this definition of a date, and it substituted in a cast statement with a format that is understood by, in this case, InterBase. This is also a statement, but it's a special convert statement that allows you to specify this is the data type I want. I want order to date to be treated as a date and not a date time or timestamp. That's one of the FireDAC scalar functions, which I'll talk a little bit about more in just a minute or two. Identifier substitution allows you to identify elements, either table names or field names, and instruct FireDAC to put the correct notation around those items to identify them as other fields or as tables. Some databases support double quotes to enclose names. Sometimes they use square braces. What the identifier substitution does is it ensures that a correct, for your database, whichever database you're using, a correct quotation is used. In this case, it's a double quote. In other databases, it might be square braces. Conditional substitution allows you to place essentially immediate if statements within your code, indicating that given a particular situation, you want one value or another. So there's a condition. In this case, I'm saying if we're using the InterBase server, enter the name order date. If I'm using Microsoft SQL Server, use a different field name, in this case order date without the underscore. If I show the command preprocessor here, it says select PO number and order date from sales, and order date is associated with InterBase, and that's the database we're attached to. The final example is using FireDAC scalar functions, and FireDAC supports quite a few scalar functions. Scalar functions, by the way, the FN part here, function, is completely optional. I put it in there just to emphasize that I'm calling a function, and in this case I'm using the length function, and so that'll return the length of the first name field. Notice here that the select statement has replaced the length part with actually a call to strlen. String length is a user-defined function in InterBase. While I'm here, I just want to say briefly that when I first wrote these examples of SQL scalar functions, some of them did not work against InterBase. And the unfortunate fact was that there's a special little SQL script that's supposed to be run when you're installing InterBase and RAD Studio, and in my case it didn't get run, and the result was that some of these scalar functions in InterBase were not available. I described this in the appendix of FireDAC or Delphi and C FireDAC. How do you do that, and where you find this SQL script. But if you have that problem, you need to look it up, and you need to actually run that script on InterBase. These same functions worked on other databases that didn't rely on user-defined functions that actually had to be created during the installation of InterBase. But in any case, this is the SQL Command Preprocessor, and this code demonstrates both how to see what the results of the preprocessor are, as well as demonstrate the use of various escape sequences in FireDAC. Our next topic is ArrayDML. ArrayDML provides for mind-blowing performance when used with databases that support batch command processing. ArrayDML employs a parameterized query along with an array of parameter values, so a multidimensional array where each array are the parameters for a particular execution of the query. The query and the array are passed to the server, which in terms is responsible for doing the parameter binding and query execution server side. And this provides you with unbelievable performance, which I'm going to demonstrate in a second. I personally just really experienced the great performance of ArrayDML with I needed to generate some very large tables, specifically tables that had more than 1 million records. I was creating one table. It had 85 fields, including blob fields, and I used ArrayDML, and I was able to insert 5,000 records a second. I created the 1 million record table in 3.5 minutes. It was blinding performance. Let's go over and just take a look at a relatively simple sample of ArrayDML. By the way, all of this code is on the code disk you can download, and the URL for downloading this code is shown at the end of this presentation. So what I have here is every time I run this, I create a table. It first of all makes sure that it's dropped if it exists, and then it creates the table, and the table has two fields in it, a date value and a day name. And then the code will populate that table first by calculating using 2 date time pickers a range of dates that we want to generate, and then we create a parameterized insert into for that table name. We're defining the data types, and then and this is something you won't see in anything else except for FireDAC ArrayDML. The params property has an array size, and we tell it how many of these records are we going to insert. And in this case, it's going to be about 3,600, because I'm going to put 10 years of data into this. I'm using a stopwatch to determine how fast this takes. Then I go into a loop where for the 3,650 or so dates that I'm going to insert, I define a date and a date description, and then I increment the date. When I'm all done, I call the FD queries execute, telling it how many elements of the array I want it to perform this execution on. And then you'll see I've got a transaction that's being used here, and I'm either committing it or rolling back. Once I commit it, I'm going to then display a little bit of the data at the bottom and show how long it took to execute that query. But this is really impressive. I'll click this button here, and we took 175 milliseconds, and we inserted every day from the day today, where I've recorded this presentation, to 10 years from today. So there's actually a a tremendous number of, well, 3,650 approximately records in that data set. Let's actually go and look what happens if I don't use ArrayDML. This is a traditional execution of a parameterized query, then binding a new parameter, executing it again and again. And in this case, it took a second, which is about 8 times slower, or maybe 7-8 times slower than the other one. So ArrayDML gives you blinding performance for inserting a lot of data, or it could not be just inserts, it could be updates, or it could be deletes. It could be used for any kind of parameterized query or parameterized stored procedure. The last topic is cached updates. Now, cached updates is a really big topic, and I don't have time to go into nearly as much detail as I would care to, but so I'm going to give you just kind of high-level view and show you a couple projects you can use to learn more about cached updates. First of all, FireDAC supports 2 distinct modes of cached updates. One is called the centralized cached updates model, and the other one is the decentralized cached updates model. The centralized cached updates model is used when you have one or more data sets and you want to maintain the change cache as one unit. No matter how many, you could have 20 data sets participating in the cached update session, and centralized model has one cache where changes to all 20 data sets can be managed. In the decentralized model, it only applies to one data set. Now, what's really cool about FireDAC is that this cached updates is available in any of the FireDAC datasets, not only FD mem tables, but also FD queries and FD tables and FD stored procs. When you're in the cached updates mode with a FireDAC dataset, you post records to the dataset, or delete, post deletes or post inserts, but the data isn't actually, those operations are not performed on the underlying database, but they're performed on the in-memory data and are stored. And their operations and all the data necessary to reproduce those operations are stored in the cache. The cache can then be edited, it could be reviewed, it could be thrown away completely before being applied. Now, you're not going to throw it away and then apply it. What can happen is that you can programmatically, or with the input of the user, look at all of the changes that the user has performed and selectively remove some changes if you want to, even going so far as to restoring deleted records and then applying the updates. When you apply the updates, those changes are written to the underlying database. And if some of the changes can't be written, then you can manage those and capture those errors and take action to ensure that the data is corrected and then written back. This is a very, very powerful capability. Interestingly enough, cached updates was originally available in the Borland database engine, but by about the time, I think it was around Delphi version 6 or RAD Studio version 6, that the cached updates was broken, permanently broken in the Borland database engine. More recently, the client dataset supports cached updates, and just about anybody who wanted to cache updates and manage the cache and then selectively apply the updates had to use a client dataset. Now with FireDAC, you have the ability to perform cached updates with any of FireDAC's datasets. So let's go take a quick look at a couple options here. The first one is I'm going to show a master detail cache. This is going to use the centralized model of cached updates. When you use a centralized model, you add an FD schema adapter, and all of your data sets are going to point to that schema adapter in their schema adapter property. And then these individual data sets are going to be placed in the cached updates mode, and it's the schema adapter that will maintain the cache. You can ask the schema adapter how many changes are there in cache. You can ask if there are any changes in cache. You can actually persist the cache for these multiple data sets just by doing a save to file and load from file in the schema adapter itself. And then you can selectively cancel all the updates, apply the updates, or apply individual updates. This particular example is designed to demonstrate cached updates with master detail relationships, so that when you go to apply the updates, they are either all applied correctly or none of them are applied. I actually running this and showing it, it's not very visual, so I'm going to go actually to another example on the code disk, and we'll look at the basic cache version, because this will give you a little bit more sense of what cached updates is doing. So with this project, I'm going to open a query, and now I'm going to enable cached updates, and then I can make changes. So I can come in here, for instance, and change this this value. Update status, I'm able to read a particular record and tell if it was a modified record, unmodified, inserted, or deleted. I can restore changes to a particular record. Let's revert record here, and I've got it back to where it was. Let's make a couple changes. So here again, I'll change the title of this company, and this one here I'll change the title of this company as well. We can now save all the changes. We can discard every change, or we can undo just the last change, and that's what I did. I undid the last change. When we're ready to apply the updates, we hit apply updates, and that now became permanent. So in this case, Dallas Technologies is back to its original title. Signature Design now has its new updated customer name. If I close this and open it again, you'll see that the updated title is there. So it's basically you're delaying your writing to the underlying database, but you can do a lot of things, including examining what the user actually changed, performing high-level validation of the data, and then selectively applying. You could actually revert some records and then apply all the rest of the changes. And there's a very powerful error capturing mechanism. Like I said, this is a very advanced feature. It's very sophisticated. There's a lot of nuance to it. And I will also say, with FireDAC, you want to be using RAD Studio version 10 Seattle or later to successfully use cached updates. As far as I'm concerned, if you're prior to Seattle, if you're using versions earlier than Seattle, such as XE8 or earlier, FireDAC does not have all the properties that it has in Seattle and later that are necessary in order to make this feature work correctly. So you really want, with cached updates, you really want to be using the later versions of RAD Studio and FireDAC. So that's it for this session. If you want to get the code samples I've been showing, you can go to jensendatasystems.com/firedaccode.zip. There's a zip file with those particular examples. If you need to contact me, my email address is cjensen@jensendatasystems.com. My company website is jensendatasystems.com. You can see my blog at caryjensen.blogspot.com, and my Twitter handle is @CaryJensen. If you want to learn more about Delphi Developer Days, which is our annual tour, you can do so at www.delphideveloperdays.com. This year I have a special, or this fall there is a special Delphi Developer Days 2017 Special Edition Database Workshop that I am doing with Bob Swart. It's a 2 days, Bob and I both together, talking about database development in Delphi. We're going to focus on FireDAC, we're going to focus on DataSnap, and we'll have material on a RAD server. So look for that. It's a very intense 2-day workshop. This is one where we are inviting you to bring your laptop if you'd like, so that you can work along in the projects while we're presenting the material. And attendees to that will get a book that contains all of the material that we're covering, including a special edition of Delphi In-Depth FireDAC. If you want to learn more about FireDAC, I have to recommend my book, Delphi In-Depth FireDAC. It's over 500 pages of material. It actually includes all of the examples that I showed you, plus many, many more. There's 45 different projects. I cover everything from basic database navigation, and which there's about 4 or 5 chapters there that would be highly appropriate for a developer who's new to Delphi and interested in learning how to build database applications. But it has lots and lots of material for the advanced developer, including material on the FDMEM table, on array DML, on dataset persistence, on virtual fields, also on clone cursors and array DML and cached updates. You can find more about that book at www.jensendatasystems.com/FireDAC book. Thank you for joining my webinar today. And immediately following this presentation, we're going to have an open question and answer session, and I look forward to hearing your questions.
Great. Thank you so much, Cary, for this great informative session and for your new book on FireDAC. I've got my copy here. I'm really excited to be reading it.
Outstanding. Good morning, Jim. How are you doing?
I'm doing well. How about yourself?
I'm doing very well. Maybe I should be saying, repeating David I's old good morning, good afternoon, and good evening.
Exactly. Okay, so we have a few questions here. If you have any additional questions, you can put them in the question panel here and go to webinar, and we'll do our best to get them answered for you. First question, is it possible to use interfaces of FD connection in order to make classes communicate only through an interface?
So when this question was first posted, I was thinking of why would we might want to do that. I know that there is that working with interfaces and accessing data through interfaces is a very important tool in a lot of development situations. The answer is yes, that the FD connection descends from an FD custom connection, and it implements the IFD stan options interface along with several others. That would allow you to work with connections through interfaces. However, FireDAC itself is a highly structured, object-oriented collection of classes that you could use the interfaces of the classes themselves, not formal, I interface, but rather through the inherited class structures from their ancestors, and that's a very good way to work through this. If you're one of those people who just really feels like they must constantly work only through interfaces, then yes, there are interfaces there that you could work through. In the case of an FD connection, I don't see a tremendous amount of benefit to that, because really if you're working with multiple FD connections, for instance, in your application, then you just use the ancestry of FD connection, or really the class definition of FD connection as a concrete class, which is perfect. The interfaces are especially useful in situations when you have different classes that are quite different in intent but support a common interface. And that's where I would be, and that's where I would see the real value in interfaces. But nonetheless, there are some interfaces in FireDAC, actually quite a few interface definitions, and then you can work for those where you find them. I had to actually look up, so when that question came up, I went over to RAD Studio and I looked up through the FD connection hierarchy and found, yes, indeed, at FD custom connection you have an interface for those properties that I was talking about at that particular time, which were the shared inherited properties of FD connection with other classes in FireDAC.
Yeah, that's one of the great things I love about working with Delphi and FireDAC and everything, is that if you have a question, you look at the source code and, oh, look, there it is. I really think that the value in interfaces with data access is building your objects with interfaces, right? And so instead of worrying about using interfaces to the FD connection components, instead you build your data access layer components that would have interfaces, and you'd use those interfaces in order to make your architecture loosely coupled in the way that it works with things. But,
yeah, really good point, really good point.
So let's see, with the FD Manager and multi-menu level project, can you place the FD Manager on the main menu and control all subsequent data components, or is it best to define one on each screen? I'm guessing you can talk about forms.
Right. Well, so the question, if I understand the question, is should I just place one FD Manager, or should I have many of them? And the answer is that you cannot have many of them. There is only one FD Manager. If you do not place an FD Manager in your project, there will be one created for you before the first FD connection connects. And then programmatically, you can work through that FD Manager to control the shared properties of all of the connections and thereby all of the data sets, except in those cases where you've overridden a particular property at a particular level. So you can't have more than one FD manager. If you do place an FD manager, the place that I would put it would be on the data module that's created at the, it would be on your main data module or your only data module. Most applications may have a couple data modules, but there's one data module that makes the initial connection to your database. I would place the FD manager there, and then you have design time configuration you can perform. So that's the answer. You can only have one. Place it somewhere where it's created extremely early in the life cycle of your application, so that it, because you have to do all your configuration of that prior to any of the connections being connected.
All right. Let's see, is it possible to compare data from two different FD queries that have different FD connections? Something like select data from SQL Server and select a separate set of data from Oracle and doing a comparison between the SQL Server and Oracle data.
Yes, absolutely. In fact, that's one of the features. It's a feature that I did not discuss in this webinar because we were limited to 45 minutes. So what I did is I picked out 5 topics that I thought were particularly interesting. There are many, many interesting topics that I didn't cover, and one of them is called local SQL. With local SQL, you can perform queries across different data sets. And when I'm talking about data sets, I'm not limiting myself to FireDAC data sets. You can perform queries between a client data set and an FD query and a SQL data set. And just in the same way that you might compare 2 tables in a single database server, what you could do is have 2 different queries, each querying a different database server, to bring records into your application, and then use local SQL to perform comparisons between those queries locally inside your application. It's a powerful technique. I will say it's a I guess the word I'll use is touchy. With local SQL, you have to be very specific and deliberate. Once you've got it working, great, it'll continue to work, but if you go back and try to tweak it a little bit, it might break, and you have to just kind of chuck the whole thing away and rebuild your local SQL from scratch. I don't know why this is. It seems that the local SQL component itself has a memory, if you will, and when you try to adjust it later, sometimes it just breaks, and I've never been able, once it's broken, it's broken. I've never been able to fix it. I just delete that local SQL and place a new one and then configure it again, which is not terribly difficult. So it's a bit touchy, but it's a really incredible feature, and doing something exactly like what we're talking about here, comparing across 2 different database servers, is something that it does. Now, if on your 2 different database servers, if you have 20 million record tables, okay, you got a problem, because you can't bring all that into your application. But if you're talking about something that's more focused and that's not working with enormous amounts of data, it's a very doable thing.
I'm a big fan of local SQL. It's very, very powerful.
Certainly
it's something I've wished I could have done years ago with different data access layers.
Yes, absolutely, absolutely.
Currently, I have a lot of code written to substitute collate in different forms for InterBase, Firebird, SQL Server, etc. I'm not sure what the question is there.
Well, the question was really, the writer was saying, wow, conditional substitution, that's incredible. What it allows you to do is to write a piece of SQL, and then right in the middle of it, where you know that your 2 different databases require different syntax, you can put this immediate if and say, well, if I'm attached to, let's see, which database, okay, if I'm attached to InterBase, then I want to use this statement. But however, if I'm attached to Oracle, I want to use this statement over here. Or MS SQL Server, there's another thing I need to use, and it could be because your database structures are different. It could be that the data types supported by the different servers are different. Conditional substitution allows you to create this one fixed piece of SQL that's executed, and with the SQL Command Preprocessor prior to FireDAC sending that query over to the database server, it evaluates this escape sequence and says, oh, okay, I'm attached to the InterBase, so this is what I use in this area. It's very, very powerful. What I really want to avoid, if at all possible, when I'm supporting multiple databases, is every time I come to a query having to have an if-then-else or a case statement of some type, just trying to evaluate what server am I attached to and what SQL do I send to that server. With the SQL Command Preprocessor and escape sequences and then macro substitution also on top of that, you can write a fixed piece of SQL, and then it will be morphed appropriate to that particular database server. So that was what that question was about, and they were just saying, all right, I'm using something else at this point, but conditional substitution is going to clean up my code.
So there's a couple questions here about array DML.
Yes, there are a couple questions here. There were a couple questions by one listener who was asking about what they could send to a database server using array DML. They were asking about row ID, which in some databases is a unique identifier for a particular row that's outside of the primary key structure of the database. And then they also asked, could they send an array of table type as a parameter? And my response to those questions was, array DML is just a way of packaging up your parameters for a parameterized query or stored procedure call, and then passing both the array of parameters and the parameterized statement to the server and letting the server do all the data binding. So what that means is the parameters you can use in these SQL statements are normal parameters. Whatever parameter you can use in a parameterized query you can use with array DML, but nothing outside of that. So you don't gain any other special capabilities other than being able to let the database server do the data binding, which is far, far, far more efficient. Instead of, for example, instead of having 5,000 insert statements that you execute one at a time, sending each one individually across the wire to the database server after it completed the previous one, you package up 5,000 sets of parameters and you take your parameterized query, you send that all to the database server in one communication. The database server will then do the data binding and execution one by one. Back when I first started playing around with array DML, the difference in speed I saw was mind-boggling. I mean, I took a query that took 6 seconds against one database and turned it into 70 milliseconds. The difference we saw in my example here with InterBase was only on the order of 5 or 6 times faster. But 5 or 6 times faster is a big deal. And like I was talking about, I needed to create some very large databases. In fact, one of the databases I created had over 12 million records in 85 fields. And that took some time, but it was so fast with array DML. By comparison, I tried using a batch move component, and after about 15 minutes, I basically killed the batch move component and looked at how many records I had inserted in my database, and I had inserted 30,000. By comparison, using array DML, I was inserting 5,000 records a second. So instead of having only 30,000 records inserted in 15 minutes, in 3.5 minutes I had inserted 1 million records. These are big differences in performance.
Yeah, that's one thing I love about FireDAC and stuff like this is there's little things you can do that you can improve performance such a huge orders of magnitude like that. It's just a matter of figuring out the best way to do things. So a question here, problems with field names not updating in bind source if the underlying table changes. Is there some tips you can provide on that?
Okay, I apologize. Let's see. Let me read that because I was just responding to another question there about where to find the code download, and it's at www.jensendatasystems.com/firedaccode.zip. So I wanted to, while I was typing that, you were asking the question, and now I'm going to go back and let's see. If I have field problems sometimes with, or have problems sometimes with field names not updating in bind source if underlying table changes. Not sure. So this, since the writer is speaking about bind source, I'm assuming this is live bindings that he's talking about. I really don't know. I would probably. It can be difficult with live bindings, especially with visual live bindings. You're not interacting directly with the live binding. You've got the live binding designer that's just generating these live bindings for you. What I would do is I'd remove the live binding and replace it. But I don't know. I don't have a better answer for that. There's a lot of great questions coming in right now.
Yeah. Is your Fire DAC book available in other formats besides PDF, for example, EPUB or MOBI?
No, it is not. We are publishing that book through FastSpring, and FastSpring has some very specific, I don't want to say limitations, because it's very nice to get the book in a PDF format because it's kind of a universal format that you can use. But no, we're using FastSpring and FastSpring's facilities for that, and we don't have options for that, so I apologize, we do not.
Okay, Wolfgang has a question here. I want to import a CVS file into a database table and use J and N for Boolean values, where all rows in this file have the same value in Boolean column. TFD batch move text reader changes value to F. How can I avoid this?
Well, that's very interesting. Okay, first of all, Boolean values cannot be J and N. What you're talking about is a char1 field, so you're not going to be able to do that. I understand why the writer wants this, and I don't know if it's possible. I'm assuming this is possibly a German language database, or the database is for a German application, and this would be Ja9 or Ja9 or something like that. And so for a Boolean field, you usually have very few limit options. It's either T or F or 0 or 1 or something like that, or -1. But if you want to use J and N, then you're talking about a char1 field, really not a Boolean field. At least that's, and I could be wrong about that, but that's what I would understand. And in fact, I work with a number of my clients have databases where they want J and N to represent yes and no, or true and false. And those are all, in those databases, those are char1 fields.
Question here says, my company is still using Delphi 5, and we are thinking about updating to at least XE3. Can you give some reasons to upgrade to even later versions like 10.3, which isn't out yet, so 10.2 is Tokyo latest release?
Well, I'll give you a very good reason. You want to use FireDAC, and you don't want to use FireDAC in XE3. It was still AnyDAC in XE3. It was still AnyDAC in XE4. XE5 is not, FireDAC's not there yet. In XE6, FireDAC started to really conform nicely within Delphi. Frankly, I would use FireDAC in nothing earlier than Delphi 10 Seattle, or RAD Studio 10 Seattle is what I'd say. Especially because cached updates does not work. Is not useful except in very limited situations in versions before RAD Studio 10 Seattle, because in earlier versions we didn't have the update options of auto commit updates, and that is an absolutely critical setting for that. Also, many improvements and bug fixes have been introduced, serious big bug fixes have been introduced in FireDAC over those years. So I want to use one of the latest versions. XE3, absolutely. In fact, the code that I uploaded won't work in XE3, it won't work in XE4. Very little of it will work in XE5. For my book, Delphi In-Depth Fire DAC, the examples were all tested in XE6. And there's a number of places where compiler directives had to be used in order to prevent the compilation of certain statements that don't work until later versions of RAD Studio. So I would definitely go with some of the absolute latest versions of RAD Studio. And I have to say, I really like Tokyo. Seattle, Berlin, Tokyo, these are really, really good versions of RAD Studio, and I would want to be as close to the latest versions as possible. And currently also I'm looking forward to the next update to Tokyo. I suspect we'll see it soon. I don't have any kind of information about that, but I'm looking forward to that as well. So go as close to the latest versions of RAD Studio you can when you're upgrading. You're going to pay a price. The Delphi 5 to say Delphi 2009 update, that's a huge leap, and it's not going to occur overnight. It'll really depend on how you built your applications, what kind of architecture you've used, what kind of third-party components you've used. I've helped a number of companies move from Delphi 5 and Delphi 6 and 7 to the latest versions, and it's not a trivial thing. You've waited a very long time. You're about 18 years behind the ball. So you've got 19 years of technological debt you're going to overcome.
Yep. Yeah. Well, and one thing is, actually, if you do upgrade to one of the later versions, you get the previous version support as well. So you could maybe jump through a few versions on your way to upgrading your code, which I've heard.
That's a very good point, Jim. I remember Bob Swart had a recommendation for people who are coming from very early versions. He said, make the leap to 2007, get it working there, then make the Unicode leap if you have Unicode issues. Not all applications have Unicode issues. If you've stuck with the constructs within RAD Studio in the C++ language and the Delphi language, you don't have to worry about a lot of the Unicode issues because those are taken care of for you through the classes and the runtime library. However, if you've written a lot of low-level code of your own, the Unicode conversion can be a massive conversion. So Bob suggested leap to 2007, get that working, then make the leap to 2009, get the Unicode part working, and then go the rest of the way. And you maybe make it 2 steps, first to 2007 and then to Tokyo. You are going to, and I'll throw this other concept out too. I had one client one time that I was helping in this process, and they came to me and complained. They said, you know, we're so frustrated because, and in the case, this was quite a few years ago, and they were using moving to XE4, and they said, hey, it worked in Delphi 5. It doesn't work in XE4. And I had to remind them, I said, actually what you should have said is, we got it to work in Delphi 5, and we haven't yet gotten it to work in XE4, which is really correct. When you wrote for any version, you know, every development environment has its quirks, and every version has its particular quirks. And when we got it to work with Delphi 5, you know, we probably accommodated a number of bugs that were in that product, and those bugs are no longer there. So it's not just a matter of, hey, if I've done everything right, it's going to work. You know, the product is constantly being improved, and there are better ways of doing things in the later versions. So it just that can be a big leap.
Yeah, actually, I was just helping somebody port some code the other day and to Tokyo that was causing an AV, and couldn't figure out why. And finally tracked it down. There was a place he was using a what was it? He was using an integer instead of a cardinal, right? So it was using a signed int instead of an unsigned int, and the code shouldn't have worked. It was basically generating unspecified values because it was an array. It was, yeah, that's right. It was a signed array index versus an unsigned array index, and so the old code was actually indexing the array into the negative numbers which weren't existing. And it's like, this was pulling wrong values before, but you never noticed, you know, but now the compiler was giving you an error message. So anyway, there's always things that change that usually it's like, oh, well, that didn't work, shouldn't have worked before. I'm not sure how that worked. So yeah, absolutely. There's always some little things you have to do, but generally speaking, it's pretty straightforward to do. Let's see, can I apply that on NoSQL, like cache update, for example?
I have absolutely no idea. Sorry, I've not used NoSQL database. I'm a SQL jockey. I'm admitted, completely addicted SQL jockey. I really don't know the answer to that. I don't see why not, however, because the whole idea of cached updates is you're posting changes, but you're not posting changes to the underlying database. You're posting them to a in-memory cache, which will subsequently be posted to the underlying database using the mechanisms supported by that database. So I would imagine you certainly can. But that is speculation.
I'm trying to remember, I've done some work with the MongoDB NoSQL support, and it seems like it did have that in there, but I can't recall for sure. That's one thing about the MongoDB support is some of the components and stuff you use are specific to MongoDB just because it is different, but it seemed like my impression was most of the functionality that you expect from FireDAC was available on MongoDB, but just some of it was slightly different. I really like the MongoDB implementation is really fantastic. I had a lot of fun playing with that when it first came out. Let's see, code using FD script dynamically created works fine from an application, whereas when it is used from within a Windows service, an error message regarding a link application is raised.
That's a very interesting question. FD script is one of those components that I did not cover in my book, and that in large part I just don't have experience with it. And here's what I would do. I would document exactly what you're attempting to do, and if it seems to be broken under the Windows or the Windows Service version, to upload a sample to the quality portal. We as database developers, there are some very fancy things we try to do, and sometimes the component library might not be up to it, and it was designed to be able to do that, but it's not possible to test every single case. And so this may be a corner case, which under a particular condition things aren't working right. Or it could be that that somehow you're attempting to do something that's inaccessible. Windows services have limits to what they're permitted to do because of the environment they're running in. So it could be something like that. So I don't have an answer for what that is, but I would document. You may want to begin by document well and writing up something, a real clear question for Stack Overflow, and if you determine that it is something that seems to be broken, I'd certainly post an example on Quality Portal.
Subjects, ArrayDML. Where can I get specific information to understand how to use ArrayDML with master detail inserts?
Well, then ArrayDML with master detail inserts. Well, the question, where would you get information of that? Well, I think you'd probably try to read everything you could, and then you're going to do some groundbreaking work on your own, because ArrayDML and cached updates in a centralized model for master detail relationships, that's not, those two things are two different and separate technologies, and you're not going to cross the streams there. So what you're talking about is in ArrayDML, you're building the arrays yourself, and you are so I'll tell you what I would do, because there is an answer to this, and that is, and it's a very interesting answer. Boy, this is, I wouldn't have ever considered this except for the question itself. What I'd do is I would use the centralized model of cached updates, and I would write an on-update record event handler to handle all of the updates. when I call apply updates, I build the array. So the array has to be visible. It has to be in scope within the onUpdateRecord event handler. And I would, in the onUpdateRecord event handler, I'd assign the parameters to the array. I would then return EA default from one of the formal parameters that's passed by reference to tell FireDAC, I have applied that update, where in fact you have not applied that update. But it'll call update on update record once for every single record in cache. And by using the centralized model and a schema adapter, you are ensuring that the updates will be issued in the correct order. Now, having said that, that just blew a hole in my thought process, because you can't just call array.dml with one query and call it with another and have them correctly done in some kind of order. So actually the answer, I've come to the conclusion, you can't do that. It's not going to be done. You're not going to use a master detail relationship or a complex master detail relationship unless it's you only have deletes or you only have inserts. If you have a combination of inserts and deletes, you're not going to use array.dml. You're just going to use the centralized model cached updates, which will apply them in the correct order. Here's the issue. If records are deleted in the master table, there can be no records in the related records in the detail table. However, you can't insert records on the other side of things. You can't insert records into the detail table until there is a master table record due to the constraints, I'm assuming, that your database would be enforcing. So it looks like array.dml and cached updates are going to be, you're not going to combine them, or you're not going to combine master detail and array.dml. It just doesn't, now that I think about it, it doesn't make sense.
You could also take a look at change views with InterBase. That's a possibility.
Well, that's an interesting technology to bring into the mix, yeah.
See, removing live binding source is what I have to do on a complicated table. Okay, so this is in reference to the question earlier, I think. Okay, yeah. So let's see. Sorry, getting when mappings have been created automatically within an FD batch move, mappings not at all. How do you avoid attempting to write to destination fields which are read-only?
Jim, where is this question? I want to really read it.
Steve Bailey's question. It's down after the DevArt tools.
Oh, okay. Oh, okay, great. So, oh, okay. I'm having a little bit of trouble scrolling around. Here we okay. How do you avoid attempting to write to destination fields which are read-only? Okay. And mapping has to create automatically. Oh, within FD batch move. You know, unfortunately, FD batch move is another one of those FireDAC components that I'm not really familiar with. And I am thinking also of something very specifically that Dimitri mentioned to me when he was doing the technical review in the book. He said the mappings, in particular, he was saying about the mappings that when fields are automatically created, mappings really don't play much of a role at all. It's when you're now I'm confusing myself. I don't know the answer to this question. Mappings that we create automatically, I think you would have to go in and modify them if it's at all possible, because it doesn't understand that those fields are not read-only. Here's another solution too, is if you can create individual field defs, or prior to using this batch move component, you access the individual T-field instances, both either at design time or at runtime, and you look at their provider flags property. And using the provider flags property, you can add or remove flags that indicate about these the characteristics of these fields. And for these computed fields in InterBase, you flag them as read-only. And so FireDAC will not attempt to update those.
Okay, it looks like probably need to wrap up here. There's still a few questions left, unfortunately. Anything you'd like to wrap up with, Cary, as far as FireDAC? Actually, I will add in, I've been to your Delphi Developer Days, and I highly recommend if anybody can attend those trainings. Those are fantastic. And like I said, I do have a copy of Cary's book, and I'm confident, even though I haven't gotten through all of it yet, that it's going to be definitely worth your time. So if you do have interest in FireDAC, do check out Cary's book, and if you can, check out Delphi Developer Days. So.
Oh, I appreciate that, Jim. I want to thank everyone who attended the talk. We had quite a large crowd for this, and I appreciate that. And thank you everyone for your questions. And Jim, I want an opportunity to sit here with the questions we have not answered online and type some answers here. So is this a possibility that we could end this session without losing all these questions and the opportunity to answer?
Sure. Actually, we can keep going. I just was trying to be respectful of your time because we're.
Well, I have time. Okay. I'm out in actually I'm in Portland, Oregon right now, and it's a beautiful morning. It's actually the first cool morning of all across the American Southwest and West. It's been extremely hot over the last couple of days. Here in Portland, we had 88 degrees yesterday, which is really unusual for Portland, Oregon. So
yeah.
No, I'm here, and I'm happy to answer each one of these that we can.
Okay. See, actually, there's one question here so DevArt tools are great. Would you recommend FireDAC? Is it worth the transition of moving from DevArt to FireDAC?
Well, FireDAC and DevArt's UniDAC both were originally third-party products, and were quite similar in terms of their scope. They were both very good. Embarcadero ended up purchasing AnyDAC, and so now DevArt's UniDAC is that third-party, really powerful, effective third-party data access mechanism outside of Delphi or RAD Studio, and it's a good product. If I was using one or the other of these, I wouldn't feel a need to shift. They're both very good. If you're not using, well, here's the real key, is that if you're not using either of them, and you have the later versions of Delphi, you have FireDAC. Now there are some things that UniDAC and DevArt's UniDAC does that FireDAC doesn't, but there are things that FireDAC does that UniDAC doesn't. So if you have one of those needs that's not satisfied by FireDAC, UniDAC is a great third-party product supporting RAD Studio, and I know that Embarcadero must be very pleased to have these really dedicated, high-quality third-party vendors that are providing tools for RAD Studio. On the other hand, if you are not using FireDAC and there's something that FireDAC has, first of all, if you're using an older data access mechanism, I would shift to FireDAC. I didn't always say that, and in fact it was when I came to that conclusion, I started using FireDAC for all my examples for Delphi Developer Days, and I also used them in my previous book, Delphi In-Depth Client Dataset. And I was like, I finally came to the conclusion, wow, FireDAC's really beautiful, it's matured beautifully, and it's now the data access mechanism I am going to recommend to all of my customers for use, but they're using, that's inside the box. So the answer is they're both really good products, and if one does something that you need that the other one doesn't, then that will make a difference in whether you go outside the box or not. But if you're not using either of them, I would really consider migrating to FireDAC, putting that into your roadmap plans for the future of your application. If your application is intended to be around for the foreseeable future, because there are that many really powerful capabilities in FireDAC.
Yeah, I've heard nothing but good things about UniDAC. It's a great framework. So yeah, I would concur with what Cary's saying. You probably want to be using one or the other. If you're not, then FireDAC's in the box, so you have that. But if you're already using UniDAC, unless there's something, and like I said, there are features that are specific to each one of them. And I've had people say, well, UniDAC does this. Why should I switch to FireDAC? I'm like, well, if UniDAC does what you need to do, stay with UniDAC. You know, but there are some things that are specific to FireDAC and some things that are specific to UniDAC. So pick which one works best for you and go to town. Okay. If index field names or index name is selected for TFD mem table, an access violation is raised when feeding it. If index is skipped, it is fed normally. The TFD mem table is populated with data from an FD query via mem table data equals query data, and the query is then freed before accessing the data in the mem table. No changes are made in the data in the mem table. Can you help?
Yes, I hope I can. First of all, I haven't seen this particular error, and there are two ways in particular of quickly getting data from a query to a FD mem table, and the other way is to use copy data sets. And copy data sets have something like 18 different flags that you could add in a set parameter that you pass in the third parameter of copy data sets, or it's actually the second parameter of copy data sets. And it allows you to indicate what you want about that structure. Consequently, I would try using copy data sets. Copy data sets is a little bit slower than just doing fd query.data. But you do have a lot of options about saying, do you want to keep any calculated fields? Do you want to keep any aggregates? What do you want? Yeah, so there's a lot of options there. If that doesn't work, another possibility is to use the persistence capability of both the FireDAC query and the FireDAC FD mem table, and take a look at, first of all, with the query doing a save to stream and then doing a load from stream using the FireDAC mem table. And in that case, you do the store meta merge and this, let's see, store merge data and store merge meta properties of the FireDAC mem table to control what aspects of that query data that you're loading from the memory stream. And that is that gives you a lot of control, including being able to handle inconsistencies with data structures. The other thing, too, would be just to do what you're doing without the index field names or index name being assigned, load the data, then apply the index afterwards. Because really, if the index field name or the index is already set on the FD mem table and you read over data, I can understand that there might be problems, because it may be when you get data from something, you're actually pulling over all its metadata and data at the same time, and so it's not like you're inserting data into the FD mem table. You're actually taking the FD mem table and populating it from the internal FD mem table of the FD query. So I would say, you know, this approach is not going to be successful on using the .data. I would use the copy data set, which actually does perform inserts into the FD mem table. However, if you've got that index definition there when you're doing these inserts, you might be building that index after every record is inserted. So I drop any kind of index whatsoever, do the copy data set or data, and then apply the index afterwards.
Okay, great tips there. Is this official support for Microsoft SQL Server, is it based on 2008 release 2 or 2012 or 2016? Do you know?
Okay, I was typing here again, turning my attention away.
That's fine. Go ahead and finish typing.
Which question is that again?
It's towards the end. Is official support for Microsoft SQL Server, is it still 2008 R2?
Oh, I'm sorry. I don't know the answer to that question.
You would need to make sure you have the drivers, the client drivers, and then it should work with the later client drivers. I'm not sure exactly what you're getting at there, but if you have the later client drivers installed, it should work fine.
I certainly know that I'm using Microsoft SQL Server 2016 and 2012 on various applications, and I don't know of any. My experience is that FireDAC has always been up to date with the latest with the latest versions of the database servers, the latest major versions, and then your comment is actually right, which is you got to make sure that your client library is consistent with that. So if I'm using MS SQL Server 2016 and I've installed that client DLL, because FireDAC doesn't talk directly to SQL Server, it talks to the local client API. So you need to have that all in sync. Everything, you have to have the consistent local driver for the database server, and then FireDAC should use it just fine. I agree.
I believe Windows comes with the 2008 drivers built in. Windows 10 does. And so if you're not, if you haven't installed any client drivers, then you'd only be interfacing as 2008 because it's just using the ones built into Windows. So I remember messing with that a while ago and discovering there was one that's pre-installed, but it was an older version. But when I installed the newer version, that made that worked better. Okay. So array DML for master detail inserts. Is that something that's covered in your book? That Daniel's asking a question where you can get more information about that?
We covered that one, and array DML and master detail inserts. No, you're not going to do that. You can't have array DML is on a table by table basis, and since a master detail, you may now if it's master detail inserts and only inserts, then you insert into the master first and you insert into the detail later, and you use array DML to do those two inserts in two separate operations. But the operation of applying updates using array DML is only on a single table level. So if you have a combination of inserts and deletes, you'd actually have to separate out. Well, now I've come up with another solution here. Separate out your inserts and your deletes. Here's you're doing your inserts. So you do your inserts to the master table first using array DML. Now you do another insert into the detail table with the inserts of those detail tables for that. Now that you do yet another array DML and do deletes of the detail records, and do a fourth array DML update of the deletes of your master table records. So the fact that we visited this question a second time gave us another solution.
Yeah, there's usually more than one way to do things. Okay. Just going through here to see if there's any questions we need to answer still. I know you're still typing answers. Lots of very nice feedback as far as people enjoying this and finding it very informative, which I concur. Lots of great information here as well. So, all right. Well, so we're looking at doing some more FireDAC content in the future. Hopefully, get you back on for another webinar in a couple of weeks, Ray. Or not Ray, Cary. I read someone's name Ray and it stuck in my mind.
That's okay. Don't worry about it. Well, yes, I hope to do so too. And I'll just say one more time that Bob Swart and I are going to be doing a 2-day. It's going to be a very intense 2-day special edition of Delphi Developer Days this fall, and it's a special edition database workshop, and we're going to permit people. Normally we don't encourage, we discourage laptops in Delphi Developer Days typically because there's so much content, we're moving so fast that we don't, if you're looking at something on your computer and you look up, you've just missed something. But this one is actually, we're going to focus on database development with FireDAC, DataSnap, and RAD Server. It's a 2-day event. We're going to be in Chicago on September 25th and 26th. Antwerp, October 9th and 10th, and Frankfurt, Germany on the 27th and 28th of November. So nicely spread out. There's an opportunity to get this into your schedule if you're interested. You can find more information about that at delphideveloperdays.com. We're very excited about this. We have a special early bird discount going on right now, 25% off of the regular price. We're already getting a bunch of signups. I anticipate that we will sell out every city because we're going to be supplying power for laptops. We are limiting the size of this to even more. It's more restrictive than past Delphi Developer Days. It's going to be a smaller group. Sign up for that if you're interested. You also have more FireDAC information in Delphi in-depth FireDAC, which was published on May 17th, I think it was. In any case, we're very happy about that. Okay, well, thanks everyone for joining the seminar today, the webinar. I really appreciate your good questions and your interest in FireDAC. And Jim, it's been a great pleasure talking with you, and I'll see you again a little bit later today, actually a couple times later today.
Absolutely. The question here, will the Delphi Developer Days in Antwerp be in English?
Yes, all of the Delphi Developer Days are in English. So yes, it will be.
Okay, and Paul says he really enjoyed your client dataset book, and he just ordered the FireDAC book. Looking forward to learning more about FireDAC.
Oh, that's wonderful. Thank you, Paul.
Yes. Okay, fantastic. Thank you, Cary, and we'll see you later today.
Yes, take care, Jim.
You too. Bye-bye. Okay, so if you have any questions, put them in the question panel here and go to webinar, and we'll get them answered for you. Thanks so much, Cary, for putting this together and for your fantastic new book I just got a copy of as well.
Yes, well, it's been my pleasure, and it is my pleasure to be here. And I see we have a number of questions to address, including a number of which that I've provided an answer for already using the questions panel on the GoToWebinar control panel. However, we certainly want to go over those together. So
in here it says, from Phil, it says data persistence. What exactly is persisted? Is it inherited configurations, override configurations, metadata records, etc.?
So when we're persisting a data set, typically you want to persist data. That's what you typically think about, and we're talking about the rows and columns of the data set. However, by default, FireDAC persists the metadata, so the descriptions of the fields, the field names, the field types. It will persist the actual data. It will persist the change cache if you're in a cached updates mode, which is very, very important to be able to persist that information so you can continue a cached update session at a later time. And then there's one more setting, which is whether a record is actually visible or not in the result set. And that may sound like an odd thing, but normally deleted records when you're in a cached updates mode are not displayed, and you can actually control whether visible records are persisted or not. So this is controlled through a stored item property, which is one of the inherited properties that I talked about very early on, and there are 4 flags to that: SI meta, SI data, SI delta, and SI visible. And so you could store only the data and omit the metadata if you're going to pass this to another data set that knows what the metadata is, and you would reduce your bandwidth. You may want to persist only the structure and not the actual data, so that you could create a data set in some other application with the exact same structure. So you have complete control over that.
So your book, it's over 500 pages, goes into a lot more detail on everything you covered here. So definitely, if anybody's interested in learning more about FireDAC, I recommend it. And it's both PDF and print version. I got my print version on Amazon, so I buy everything on Amazon.
So, and actually, we published that book through CreateSpace, which is associated with Amazon, and so the print book is through CreateSpace. We use FastSpring for the PDF version because they have a lot of support for the ebooks that we need, and Amazon, selling an ebook through Amazon it's not an optimal thing. Amazon takes way, way, way too much royalty, considering the fact that they're not printing anything. So that's why we're using FastSpring.
Does cache work only in a single user environment?
Oh, absolutely. So we're talking about cached updates. This, Jim, which question is this? I'm looking at the.
It's from
I see
Boris.
it here. Yes, from Boris. Okay. Does cache work only in a single user environment? No, it does not. It is designed. It can. I was thinking a single application. The cached updates totally works in a multi-user environment, but the issue is the same issue you're always going to have with the resolution of the data to the underlying database. One of the options you have, and this is one of the configurable options is the update mode. And that controls whether the changes cached by one user, when applied to the database, will override or overwrite changes made by other users, or will respect the fact that another user posted first the same data and that the record needs to be reread. So if you consider what happens in a non-cached update setting, that two users may read a record by executing an FD query, and then one user posts a change to that record, and then another user posts a change to that same record. Well, those rules are no different in a cached updates mode or not, whether it's in cached updates mode or not. What will happen will depend on the update mode setting in the resource options, where you say that, or in the update options, I'm sorry. So it's the update options update mode. If it's set to key only, then it's going to use the primary key, and if it finds a record with that primary key, it will replace whatever other fields are there. That's the default with FireDAC, which quite frankly I don't like. I think the better mode is update where all, where the where clause of the update statement or the where clause of the delete statement includes all fields that are in the record. And that ensures that the first person to post will have their record preserved, and anyone subsequently posting to that record who read the data about the same time will be told that that record was changed by another user. And that's appropriate because that signals to a user that they cannot post their changes because that record's no longer there the way it was. In the update key only, it's the last user whose data gets written to the database, and the previous users who posted to the record, they have no idea that their data was never saved. So basically we're using pessimistic locking in FireDAC. Very few databases support the optimistic, lock it and I'm the only one who can write to this record until I unlock it. So the answer to the question is cached updates mode is definitely very, very useful in a multi-user environment. It's just that some records may not be postable if there's contention for individual records. In an awful lot of multi-user databases, though, there's a certain sense of user affinity to records. So I'm a account manager. These are my accounts. Nobody else should be changing my accounts. I'm the one that changes the accounts. And in those kinds of environments, you get very, very little conflict. But there's I go into quite a bit of detail about how to handle errors if a record can't be posted during a cached update session due to possibly changes made by other users, and how you handle that. But it's very logical. It can get a little complicated, but it's no more. If you think about it, it's really no more complicated than posting one record at a time. It may fail and it may succeed depending on what other users are doing to the database.
Great. Can cached updates provide locking on the server?
Absolutely not. Cached updates doesn't do any locking whatsoever. Cached updates just says we're going to write all these changes in one single, in one short burst. So all the posts that you make are being held in memory, and then when you say apply updates, it all happens very rapidly. Like I said in answer to the previous question, there's really no optimistic locking. You can't lock records. Now some databases, things like Paradox actually support that, but most of the databases we're talking about, Oracle, SQL Server, InterBase, PostgreSQL, and all those, we have to rely on pessimistic locking. So there are no locks, there's no resources. The cached update session itself may last for days. It really can, because you can persist the cache and then load it again later. And when you come back to that point where you say, okay, now I want to apply all my changes to the underlying database, your code can do things like validate the data, make sure that it makes sense to post even before it tries to post, and then it tries to post in a very short duration transaction. And then if, depending on how you call updates, that transaction actually may be committed or rolled back. I actually wrap a transaction around my call to apply updates. But there, there's no locking in a multi-user environment when you're using cached updates. It all has to do. It's the standard way that database or that Delphi writes to databases, even on a record-by-record basis. It's just the same with the cache updates.
So Russell's asking if you have some good information on setting up connections. Is that covered in your book?
Chapter 2 of the book, which is a very long chapter, and Dimitri, the creator of FireDAC, actually told me, he says, wow, this chapter is too long. Well, I don't think so, because the most important thing to me is setting up the connection and doing the connection, because there's 3 general types of connections, and they can be divided in this a couple different ways. They could be called, they could be named connections or non-named connections. And depending, that allows you to control whether or not a connection pooling is available to you as an option. And then there's also temporary versus persistent connections. And basically, yeah, Chapter 2 of my book does cover that. It covers connecting the persistent, temporary, and private connections. It talks about named versus unnamed connections. It even talks about how to use ODBC drivers to connect to, for instance, old Paradox or DBase files. And that's necessary because FireDAC is an excellent replacement for the Borland database engine. And some applications, legacy applications, because of their nature, must support those old file types, especially if they're interacting with a system where those old file types are used and there's no way to update those existing systems. You'll find a lot of connection information in the online help for FireDAC, but you have to poke through it. I mean, the online help is extensive. It's very, very good, but it's not. It's organized oh gosh, I'm blanking on the phrase I want to use. It's organized as a group of single pages that you can link, that are all interlinked, but that doesn't conceptualize it topic-wise. And so Chapter 2 of my book actually does that. It organizes it in a conceptual way and then provides you the information. But you don't need my book in order to learn how to configure. Just look up making the connection. Look up the connections. If you poke around enough, you'll find all sorts of information about what your options are in the connections. And then the configurations, once you make a connection, the configuration is so terribly important, because depending on your configuration, FireDAC's going to perform those operations one way or another, and they can have those configurations can have a really big influence on how things are, how the operations are actually performed. Right.
Yeah. I found there's a page for each database in the doc wiki that covers the configuration, setting up the connections for each database. So that's usually the best way to go, and it'll talk about like what drivers you need to have and what platforms it's supported on and stuff like that. So it's pretty useful there. Field property is set, read only is set, and update flag is set to false. Only the where flag is set to true. I'm getting the feeling this is a continuation of an earlier question.
This is a continuation of an earlier question, except it was asked by somebody else, I believe. Let's see, wait a minute. No, it is the same person. So what they were saying is that they have a situation with persistent fields. That means fields that you've created at design time using the fields editor. They are, and so some of those persistent fields are associated with aliased fields or calculated fields in the select statement. What's happening, they're finding, is that FireDAC is trying to write back to those fields, but they're not real fields in the underlying database, so they get errors. This is, I have addressed this personally in my code in the past. Normally FireDAC does an excellent job of determining which fields are read-only and which are not. And it does that through, and I'm looking over at my RAD Studio right now, and I'm going to bring up the exact properties, but let me see here. It is in the update options. There's properties called check read-only, check required, check updatable, and by default those are set to true. Typically, FireDAC's going to figure out which fields it can write to and which fields it can't. Even in heterogeneous query, query that queries more than one database, it can recognize what the base table of the query and what are joins, and it will not typically write to the joins. What I had suggested in the answer to that question was that to check the read-only property of the persistent field, and possibly look at the. Now I actually erased this before I posted it, but I was going to say you may want to also look at the provider flags of the individual persistent fields. If I can remember what there seemed to be one other step that we took. But I think that may have been it, and that resolved the problem. So I've seen the problem in the past and have been able to resolve it. Now that I'm thinking about it, I'm actually thinking about an alias field that we had to do something just to say, actually don't try to write back to the field name that appears in the data set, but write back to this underlying field. Even if there are problems like this and it turns out that you can't set up the configuration, what you can do is create an on-update record event handler. And this works whether you're in cached updates mode or not. And what happens is when the record is being written, the event handler actually triggers, and then you can specify either directly through determining what kind of change is being made, a deletion, insert, or an update, and have your own SQL executed depending on the contents of the change, or you can use an FD update SQL component to actually simplify that a little bit. But there's a number of ways of getting around a problem. If FireDAC can't figure it out, you can typically configure it or write an event handler that will handle the special case directly.
Okay. How about working with console applications? Is there any issues with using transactions with explicit with MySQL drivers?
So I'm just posting an answer to that now. I'm not aware of any problems in that case. There's nothing about a console application that's particularly special in this case. We're talking about a Windows console application using FireDAC. You do need to have the MySQL client driver available, but there's nothing about a console application that would be any different than because these commands are being issued directly to the database. When you are working with transactions, you really need to make sure that you have structured your code properly with a try except clause. Specifically, is immediately after entering the transaction, you should enter the try part of a try except clause. The very last statement in the try clause should be a call to committing the transaction, and in the accept clause there should be a call to roll back the transaction. When that is structured properly, things usually work very, very well. And it doesn't. A console application is a Windows application using FireDAC. There's nothing special about that environment that would prevent it from not working correctly.
Okay. SQLite implicitly defines aliases for a record number column, whether that column is explicitly declared or not. In XC5, this caused connection operation problems. Is that fixed in later versions?
I don't know. I don't know if it has, but I will say this. I have seen that that FireDAC has received many, many improvements and has become much more mature and hardened in later versions of RAD Studio. So I would certainly try something later. I do not recommend using FireDAC in XE5. It was the first version in which the FD prefix was used, and in fact, I highly recommend that you be using RAD Studio 10 Seattle or later, just simply because FireDAC is much, much better. In the very early days of FireDAC, I ran into lots of problems, and recently, as I've used FireDAC, I've not had those problems, and so many different things have been addressed. And that's very fortunate, and that's why, in fact, I wrote this book at this time. I waited until FireDAC became what I considered a really, really solid solution. And not that it had big problems, it did have issues. Once a lot of people were using it, they found problems that were addressed and fixed in the later version. So I would be using, but I don't. The answer to this question, I don't know if it's since been fixed, but an awful lot of things have been fixed.
So here's a question here: which is better, FireDAC or UniDAC? And UniDAC, you don't need client drivers, which is great for mobile apps. Is FireDAC doing the same sort of thing?
There's no real. I guess the answer to the question is the data access framework that is better is the one that supports features that you need that is not supported by the other. If both feature sets are the same and you don't have UniDAC, you probably don't need UniDAC. If you're using UniDAC now and you're very happy with it, stick with it because it is a very, very solid product. If UniDAC, now the writer says UniDAC doesn't need client drivers for mobile apps. That's not correct. It doesn't need client drivers for several databases. Oracle is one of them. I think it does. There's just a small handful, however. You know, it does need the client. It cannot directly communicate with Microsoft SQL Server. So it does have the ability, if you're using Oracle, great, hey, you can write mobile apps that connect directly to Oracle without going through an intermediate application like DataSnap or RAD server. So is FireDAC going to add support for driverless or client driverless connections? That would be very, very cool. I could probably say it's not likely to happen with all drivers. I don't even know if there's any plans to add that. It's something I'd love to see. This is a very similar feature to a Class 4 Java driver, which requires no client. Those are kind of the gold standard, if you ask me, in terms of drivers, and it's great for mobile applications, yes, because you can talk directly to the database server rather than going through middle tier.
So see, there's an elaboration on the question about the console app, or let's see. Yes, console app. He says, the console application with data module, I have a TFT connection on MySQL. I set the TX options dot auto commit to false, even though this options set when I made an update to FD query command without FD connection.commit, the data on the database is updated.
Well, that's a very interesting, very interesting. I would have to see more. I would have to know more. I don't have the information to answer the question. It should. So the TX options is one of those, is a property similar to fetch options and format options and update options, except it applies only to FD queries and FD transactions. And it is associated with configuring the transactions. The auto commit, the auto start properties of the TX options are used to cause FireDAC to automatically wrap a transaction around the any commits. And certain types of databases, you don't want to do that. It's really, really valuable for InterBase, since InterBase requires a transaction. So I would say look at the auto start to see if that's also set. But I'm really kind of surprised that with no explicit call to commit the transaction is actually, apparently the query is being committed in the transaction. It could have also something to do with the isolation mode. I'm really not sure. That's I don't have an answer to the question.
Sorry about that. Someone rang the doorbell and my dog got upset. He's usually not down here, but he snuck down earlier when I was looking. Okay, is it necessary to distribute FireDAC libraries together with your own application?
No, FireDAC is written in Delphi.
Yeah.
And so the only thing you do absolutely have to make sure that I'm typing to another question too here at the same time. I'm multitasking. And having said that, I was triple tasking and then I lost the first one.
Is it necessary?
You need to have that. Okay, I get it. I remember now. Yeah, you have to have the client library if you're talking to a database that requires a client library. So, but otherwise, there's nothing else. It's not like Midas.dll or anything like that has to ship because, and this is the beautiful thing about FireDAC, it's written entirely in Delphi, so it's compiled into your application, and it's totally cross-platform as well.
Yeah, you can do runtime packages, but you don't have to. It's just just like you do with any other application. Okay, I think we've gotten through all the questions here, which is great. Is there an easy way to store a history of updates to a database?
That's a really good question. I'm glad that you revisited that, or we're visiting that now, because the answer is actually quite interesting but can be complicated. So let me find exactly where that question is in the list so I can be...
It's towards the top. It's 40 minutes after
Oh,
that.
I see it there. Yeah, Russell Thompson asked this. Okay. Is there an easy way to store a history of updates to a database? Probably there's two easy ways. One is that you write on update record event handlers for your data sets, and when they trigger, you create an audit trail. You manually create an audit trail. But that's happening within your database application. The on-update record event handlers passed a reference to the data set whose current record is the record that's being updated. You can use the old value, cur value, new value, and value properties of the individual T fields to be able to determine what exactly has changed on changed records. And you're also passed an indication of what kind of change is being made, an insert, update, or delete. And then you could use that information to execute queries to create an audit trail. Another easy way, but requires a lot of planning, is to write triggers on your database so that when changes are posted to the database itself maintains information, possibly performing queries and inserting into companion tables. So if you have a table called customers, you might have a customer history table that contains those changes as they're posted. And there you could capture, typically databases let you capture the signed in user, what application is being used. There's a number of things that might be valuable there too. Those are just two examples. Another example is to use cached updates, and but you would still rely on the update record event handler, I believe, in most cases. So there's two relatively straightforward ways to capture history information. And people do those things. I've seen both techniques, the on-update record and the trigger-based database version, to do the history information. Also, we might mention that InterBase as a database has some advanced features that have been introduced in the last few years that allow you to examine changes that have been made since a particular point in time.
That's true. Those are really powerful there. So yeah, we can totally get into that. But I think we're going to wrap it up for now. Thank you so much, Cary, for putting this together. You're certainly welcome. It has been my pleasure. And I'm going to sit here and I'm going to probably answer a couple more questions that we have before I disconnect this session. I do want to mention that we have announced Delphi Developer Days Special Edition Workshop with Bob Swart and me. It's an intense two-day workshop that we are visiting. We're going to be visiting Chicago on September 25th and 26th, Antwerp, Belgium from October 9th and 10th, and then Frankfurt, Germany on November 27th and 28th. It's an intense two-day workshop. Our main focus will be FireDAC. We'll have a very heavy dose of DataSnap and also include some information on RAD server. This is we have a very early bird special currently available, which is a 25% discount. If you register soon. I do expect all 3 cities to sell out because we are limiting the number of people to attend because we are going to provide power for laptops. We are not discouraging people from bringing laptops. If they want to bring laptops, great. They can follow along with the code samples that we're covering and can experiment some. Laptop is not required, but it's definitely an option this time. Bob and I are going to be working these topics simultaneously, so it's 2 days of a joint session on database development, and I'm really excited about this. I'm sorry, did you?
We're a third
Oh, apparently our Chicago city is already a third full. So we just announced this last week. So yeah, seats are going. I recommend you go online to www.delphideveloperdays.com and check it out if you're interested. And I'm really looking forward to that.
Yeah, I've been to a few of your events in the past, and I think they've always been sold out when I've been there. So I
so we appreciate.
Well.
Well, thank you very much for that, and I really appreciate your coming by. You've come by as a guest speaker a number of times in your capacity there with developer relations, and we really have appreciated in a number of cities you did an evening session, including letting, I remember the one in Baltimore where you let Nick Hodges try to control your car with his brain.
Yes.
Nobody was hurt, okay? So don't worry about this, listeners. Nobody was injured in this thing. Even though Nick Hodges is potential, Nick Hodges' tremendous thinking capabilities were placed into the mix. Nonetheless, yeah, there were no injuries. No one died.
Yes.
So, excellent. Well, Jim, it's been a real pleasure, and we've got one more session later today.
We do.
And I'm looking forward to that one as well. And I thank everyone who attended today. It was a lot of fun.
Great. Yes, thank you, everybody.
Okay. Bye now.